Welcome to here. 1, 2, 3 here. 1, 2, 3 here. Now, here my probabilities for this random variable. Let me write here. Probability x1 is equal to 1. Probability x1 is equal to 2. Probability x1 is equal to 3. These are the probabilities here. Similarly, I can continue writing probability x2 is equal to 2. Probability x2 is equal to 2. Probability x2 is equal to 3. These are the probabilities. It will continue. And here, let me correct it. This is 1. So these are the probabilities here. These are the probabilities here. These are the probabilities here. In a discrete time stochastic process, when we talk about time points 0, 1, 2, 3, we move from here to here. These probabilities are given, will be given. Whenever these probabilities are given, these are 1 to 1, 1 to 2, 1 to 3. Let me write here 1, 2, 3 states, here 1, 2, 3. When these probabilities are given, in practical cases, these will not be given. You need to estimate the probabilities from the past sample. So once you have these probabilities, you know P11, P12, P13, P21. These are the probabilities. And remember, when we talk about probabilities, they operate in discrete time. Then P31, the time is your choice. You are analyzing every hour, every day, every year, every 10 years, it doesn't matter. This duration, this duration, this duration, this duration, they are the same. That's all. 1, 2, 3. Okay. So it could be 1 hour, 1 day, whatever. I already discussed. We are not worried about that. Now, given these probabilities, we can get these probabilities from these probabilities. That's all. 3 states I've taken here. Okay. Suppose I'll write one diagram here. This is state 1. This is my state 2. And this is my state 3. What if this is a continuous time stochastic process? So you can go from here to here, or maybe I'll do this way. These are the 3 states. You can go from 1 to 2. You can go from 2 to 3. And these are the transition intensities. I'm talking about continuous time stochastic process, not discrete time stochastic process. What you see in the left, that is discrete time stochastic process. Now, what if you are discussing a continuous time stochastic process? Let me write the states 1 to 3. The same diagram we can use. So you can go from 1 to 2, you can go from 2 to 3, but you can't go from 3 to 1. Can I take the states healthy, sickness, and dead? No. In this example, no. Because practical, if you see, someone who is healthy now, one can become sick. And someone who is sick now, there is no way he can become healthy in this diagram, because there is only one way, 1 to 2. 2 to 3 is possible. 3 to 2 is not there, that's fine. 3 to 1 is not there, that's fine. But you don't have 2 to 1. So we'll not use this way. Okay, so this is not fine. Even the other day, if you remember, I solved another example. This example, not started studying for the upcoming examination. Someone already studying, someone completed studying. Okay, this example also we can't use, because somebody who is not studying, one can go to this state. Okay, studying to completed. Okay, fine. But not studying to completed without studying, this is not possible. Okay, if you don't remember, that's a separate thing. But yeah, this we can't use here, that example. Now let me go back. What we can do is here, suppose claims they arrive, or someone appeared the interview, or we can say someone applied for a job. Okay, applied for a job. So I can write job application. Let me write application. We'll make it a little bit bigger, because mostly we'll spend 70% of today's time on this question. So the question says, if you see carefully, question says 3-state time homogeneous Markov jump process is determined by the following matrix. The matrix is given. The distribution at time 0 is given 1 by 3, 1 by 3, 1 by 3. Determine the distribution at time 1. That means these probabilities are given. The probability at 1, 2, 3. And the transition matrix is not given. Okay. This is not transition matrix. This is generator matrix. So if you get a transition matrix, then the work is done. But it's a generator matrix. This is not transition matrix. How you know it's not transition matrix? If you remember, transition matrix probabilities are always, if you see, they are positive and they sum up to 1. These are the transition matrix probabilities. If you add 1 to 1, 1 to 2, 1 to 3, they should be 1. Even if they have not said here generator matrix, normally you will get in the question, even if it's not there. You have to know that we are talking about a continuous time stochastic process and generator matrix is given. If you remember, I have explained already generator matrix in the last class. If not, you can watch the last video. So now these probabilities are not given. So what is given? This is given. So what we want actually, we know the probabilities here. Let me write the probabilities here. I can write this way also. Probability x0 is equal to 1. That is given 1 by 3. Let me write x1, x2, x3 all here. So xi I can write because all are equal. Let me write xi. I don't have space. So let me write for every I, xi is equal to 1 by 3. Okay, these probabilities are 1 by 3. Here, this probability, that means probability of staying in state 1 given 1 by 3, state 2 1 by 3, state 3 1 by 3, around 33%. Now at this time, suppose there are 300, 100, 100, 100 are here. Okay, I can write like this: 100 students, you can say 100 students applied, you can write application received. Okay, second state is the interview process, sometimes without giving interview also, without taking an interview. Company, when they satisfy, directly they call for the final, you can say face-to-face meet, you can say. Okay, this is before getting the job. So this one is the final one, A, I, F, you can say. These are the 3 states. A direct way from A to F. This is A. This is the final stage of the interview, or this is final, you can say. Confirmed, you can say. This is interview. So here to here, naturally, someone will go this from interview to final, but from directly application to final. For example, I am saying, you just take it. And it happens in continuous time. Okay, you might get a call at 11:10, 11:12, 11:15, that way. This is a continuous time stochastic process, but the diagram is not continuous. Okay, instead, suppose this one is given for you. Suppose you get a matrix like this, transition matrix, 1 year, you can say. Okay, how many they will go from 1 to 1, 1 to 2, or every day, you can say, every day. In a company, how many will move from 1 to 1, 1 to 2, 1 to 3? This is discrete, right? Given generator matrix, these are continuous. These are mu's, transition intensity. These are mu ij's. Now, what is the question? The question says, determine the distribution at time 1. So at time 1, you need to find all these values. That means they are saying you to find these values at time 1, these values at time 1. That means they want you to find values. Here the probabilities they want actually. Okay, after one time period. One time period could be 1 year, according to your example. It could be 1 day, whatever. But intensities are given. So what you need to do is, you need to find, let me write here. You need to find, these are the intensities. These are the intensities, mu11, mu12, mu13. These are given. Mu21, mu22, mu23, mu31, mu32, mu33. So from these intensities, you are supposed to find these probabilities. P11, P12, P13. If you get one-time probabilities, P21, P22, P23. This is for discrete time. So what's happening here? Conceptually, you need to understand. It's very easy. What is the conceptual part? The conceptual part is, from intensities, we want to find the probabilities. From transition intensity, we want to find the transition matrix probabilities. Okay, the transition matrix. So how can you find? That is the question. How can you find these probabilities from these intensities? So if you remember, I discussed last time, All these values we can get, but not only for 1 year, because they want after 1 year. So there is no such formula. Even there is a stronger formula. Now again I am repeating why we use Kolmogorov's equations to do this. So we'll get, in fact, for 1 year, for 2 years, for 1 month, for 1 day, t you can put anything. So Kolmogorov equations, they will give you these values. Let me write properly so that there will be no confusion. And even in this class, we'll do one problem so that you will be able to do all the problems. So this way, these are the mu's, mu11, mu12, mu13, mu21, mu22, mu23, mu31, mu32, mu33. So if you use Kolmogorov's forward equations, I will do that now, you will get these probabilities. So we'll do one by one. Okay. So we'll try to find, first of all, this probability. We'll try to find this probability one by one. This probability, the probability is P11, suppose P11T, you need to find. Okay, that is the first one. Because ultimately we need P11, P12, P13, all this. So what is given here? Given here. So if I consider this is a very small time. Okay. So this is what given. Of course, this is not conceptually correct, because you can draw. This is so small that you can draw it. But for understanding, yes, you can, right? So this point is so close to 0 that I can't write. Okay. This is very close. This is a point. These 2 points are here. These are given. These are given 1 to 1. Let me write here 1, 2, 3. Here this is given. This is given. This one. Acha, I can do, no problem. Either this one you can say, or you can say this one. They are the same. Okay. These are given. But what we want for 1 year. We want for 1 year. We want for this 1 year. This whole. And that 1 year is, that means from here to here, 0 to 1. So that one will come from here, P11T. After finding P11T, you have to put T1. Then you will get your first transition probability. Now this is the differential equation with respect to Pijt. That is equal to multiplied by mu kj. Remember this one, this is forward differential equation. Remember, I always say this one. Suppose you need to do this task. Okay. This is a very important, I can say, analogy you can remember. Suppose someone says you complete 1 to 20. You divide into 2 parts. How you can divide? 1 to 19, then 19, 20. Okay. You think logically, you think this way. Then what you can do? Then you say that, okay, I can do 1 unit at a time. This one is over. Let's not worry about 20. I will worry from 1 to 19 only. Then what you can do is, again you do that the similar way. 1 to 19 you divide into 2 parts. This part. Then you say, I'm fine with this 1 unit. This 1 unit task I can do. No worries. Let me worry about 1 to 18. Again you divide. So that way you will be able to do everything. This is called forward. Forward means what? You take a big one first and small one. In case of discrete one. Okay. This is discrete. In case of continuous, what will happen is, this is bigger one anyway. This big one, this is small one. The big one you can say this P, I, K, P in T time. In T time, what is the probability that you will move from I to K state? And at K, you will make a transition. This is transition intensity. This is not probability. Okay. If you studied CM1, this is like your mortality. So this is the formula. Now you need to differentiate and you need to find all the ways possible. Okay. So we'll apply to P1 to T. If you apply to this one, it will be P11. So 11 means you have only one choice. You can write P11T. Then you multiply with mu1 P 1 to t mu 2 1. It's like 1 to 1. Okay. Starting one, ending one. You have to match. P 1 3 t mu 3 1. Okay. And differentiation also I need to write here, d upon dt. So what will happen here? Mu 1 1. Mu 1 1 is given -3. That's there. What about mu 2 1? 2 to 1. 2 to 1 is 0. This is 0 given, right? This mu 0 given. This is 0 given here. So this will be 0. 3 1. 3 1. You check 3 1 is also 0. This is 0. You see here the question. I'm rounding here. This is also, these two are 0. So by virtue of this will not contribute anything. This will not contribute anything. And finally, you will remain with this one. So let me erase all. Second and third term. So these are not there. Now you need to solve this one. Mu 1 1 given -3. And remember, mu ii is equal to minus summation mu ij. Okay. So that means if you add these two, always, this is something I'm sure you must be knowing. If you add these two, you will get the diagonal one. Okay. Main diagonal one, -3 here. These are the off diagonal elements. I mean, intensities. 2 plus 1, that should be -3. There is a proof also. Now you need to solve this one to find P11T. You need to solve. Acha, d upon dt disappeared. D upon dt disappeared. Let me write d upon dt here. You need to solve this equation. Okay. So if you want to solve this equation, you write here d, I've taken y, dy upon dt is equal to -3y. You can solve this, right? So if you solve this, this will be 1 upon y. You will get ln y log y. dy is equal to -3. That way it will be log y is equal to -3y. Sorry, this is t. dt comes here, right? 3 dt. So 3t plus constant. Okay. Then you put y value p11t. So log y value, let me write p11t here. p11t. T I will put, suppose 0, p110. Okay. That is equal to, put t0, c you will get. So what is p110? In 0 time, what is the probability that you will move from 1 to 1? Yes, you are in 1 only. So that is 1. So log 1 is 0. So c is 0. That means finally log y is -3t. So y will be e power -3t. Okay. So y is from here, because c is 0 now, y will be equal to e minus y is p110. p11t. p11t will be equal to this here. E power will go there, C0, so e power -3t. This is my answer, e power -3t. Now the question is, do you need to do this way? Okay. For the equal cases, 1, 1, 2, 2, 3, 3, diagonal probabilities, you don't need to do this way. Okay. This is, this came from Kolmogorov's forward differential equation. Okay. We solved the differential equation, we got this answer. But when it comes to occupancy probability, suppose I'm occupying in a state now, I'm teaching here. What is the time I will teach before changing my state to the other? Like, suppose I will watch some match, cricket match, or I will study, or I will go to bed, or I'll go to my supper, whatever. Okay. That state before changing, how much time I will stay here? That is called occupancy probability. Okay. So let me erase all this. Directly we can find. What is that formula? Let me write that formula. Then what is the formula for occupancy probability? So whenever you find P I T, okay, that will be equal to, that means your occupancy time is T, e power minus summation mu yj. J is not equal to y. This is the formula. There is an integration sign. I'm using the easiest one for you. So if I want to find P11T here, that will be equal to e power. You need to integrate also. Mu ij, you write mu ij's means here 2 and 1. Okay, this 2, this 1 and this 2. Summation, that is -3 anyway, minus minus plus 3. So what will happen is you need to integrate also, like I left here, which is this one, minus dt. You need to integrate. Okay, you have written t here, so we'll write 0 to t. This is the formula. So if you sum all mu ij's, okay, j is not equal to y, that is 3 here. So I'll write minus, this is 3 here, integration, this is a constant dtt, t minus 0. 0 to 1 here we are finding. Let me write 1 here. Okay, we'll keep it t only, right? All right, this is minus 3t. We'll find 1 ultimately. So you can find this one directly. And also, because this is occupancy probability, we have to write bar bar. Bar here, bar here. Now, fortunately, in this example, P11 is equal to P11 bar. If they are not equal, you have to use this formula. Okay, Kolmogorov's equation formula. Fortunately, in this example, P11T is P11 bar T. That's why we can write directly this way. E power minus 3T. This is over. E power minus. So the first one is over. We have many left now. Okay. So P11T is over. Similarly, you can find P22T, P33T. So let me summarize everything. Now, why P11T is equal to P11 bar T? This is because in this example, once you leave, let me write states here. Once you leave state 1 here, suppose I write state 1, 2, 3, because there is only one way, 1 to 2, 2 to 3, 1 to 3. What will happen is, once you leave this state 1, there is no way you can come to 1. So what we are saying is, when we talk about occupancy probability, suppose I write like this, and these are the states 1, here 1, okay, this is the time. In this time, what is the probability that continuously you stay here? Okay. If you want to see that, because there is also a way you can go here and you can come here. Okay. Like suppose I'm teaching now. I started teaching from here. What is the probability that I am teaching continuously without going to any other state? That means it's like this. So here bar will come. Okay. Continuously staying in the state. Suppose this is 1, this is 1. So there is also a possibility you can go to 1. I can go and take a glass of water. If that time someone observes me, I changed my state. Then I came back at 1. Okay, when somebody watched me, somebody can ask whether you were continuously giving class. It's like you must have seen. Suppose I'm sick. After 1 year, someone will come and see me sick. He might ask me, "Oh, you are sick since last 1 year." I can say, "No, I was well. Just now I felt sick." Okay, that I can say. So that's a separate thing. Bar will not. Bar means continuously staying. That is where occupancy probability comes. You occupied the state continuously. In this case, what will happen? Both are equal, because once you leave 1, you can never come back to 2. So staying in 1 means continuously have to stay to 1 only. There is no way you can go back. You can go out of 1 and come back to 1. So in this case, they are equal. If they are not equal, there is a formula for this one also. I mean, you can use it, or directly you can apply Kolmogorov's equation. Now, you apply the same one for 2, 2 as well. So you do one thing, you make it 2, 2 here, 2, 2. So if you change it to 2, 2, so if you add 0 plus 2 here, okay, these are 0 plus 2, so you will get 2 here, right? How about this, the third one? 3, 3. 3, 3 if you put here, that is 0. 3 if you put, because the mu's are 0, e power 0, that will be 1. Let me write all here. So at least I'm able to get the diagonal ones. This one, this one and this one. These three I got by now. Yes, 0 plus 2, 2. You will get this only. How about P33T? 3 to 3. You will get 1. You can check it. These three I got. Okay. Even I don't need to find everything, because what will happen is when I get P12T, this is the difficult part. Okay. P12T, P12T, because I have P11T, and we know that P11T plus P12T plus P13T, that is equal to 1. What will happen is, if you find any one, suppose you find this one, you have already the diagonal one, P11, you know already this one. If you find this one, you know this one. So we'll find one. Okay. We'll find one here. We'll find this one. Then you go to the next row. Next row also, we know already the middle one. So we'll try to find P21T, we'll try to find. Then P22 we have. So P23 anyway we'll have. So P21T, if I write differentiation, dash I have written P21T mu 2 to 1, 1 to 1. That's 2 to 1. Plus second one is P2 to 2T mu 2 to 1 plus P2 to 3T mu 3 to 1, right? So here you check mu11, mu21, mu31. Mu11, that is minus 3. Okay, that's fine. Mu21. Mu21 is 0, mu31 is 0. So by virtue of that, these two will be 0, because mu's are 0. So only one term we have. So let me write that term. This one we need to solve. This equation we need to solve. What is mu11 dt? So 1 by y will come. So you will get log P21T is equal to mu11. Mu11 is minus 3T plus constant. So what will happen here is, if you put the boundary condition P21 0, suppose in 0 time, can you go from 2 to 1? No, in 1 time also you can't go. Okay. In 0 time though you can't go. So what will happen? This will be 0. So we'll make it 1. Log 1 will be 0. So if you write 2 to 1, in 1 year, 2 to 1 you can never go. This is a probability, right? So this will be 0 anyway. So if you write 0 in 0 time, 2 to 1, impossible. In 1 time, 2 to 1, impossible. This is impossible, right? So if you take this one that side, okay, e power. So it will be like this. This will be equal to e power minus 3t plus 0, right? So when t is 0, this probability is not existing. That way what will happen is, when you solve this one P1 to t, that will be 0 only, because otherwise it will not be satisfied, right? So the only problem here, if you see, is while solving P1 to t. Otherwise, nothing will give a problem. Okay. Once you get 1, 2, then you get 1, 3 also. I'll show you all the solution. Now, why 1, 2 creates a problem? Because what will happen is, when you write 1, 2 dash here, it will be P11 t 1 to 1 and mu 1 to 2. This one you will get, plus P12 t mu 2 to 2, 1 to 1, 1 to 2. Then 1, 3, P13 mu 3, 2. Now if you see mu 1 to 2 to 3, 2, 2 is this one. So mu 1 to 1 to 2, this one. Then 2 to 2, this one. Then 3 to 2, this one. So this one is 0 anyway. So this will not come. This is over. Only we have 2 terms. Now when you have 2 terms here, that will create sometimes problem. Okay. So if you put mu1 to here, what will happen? If you put mu1 to here, I'll write P12 t dash 1 to dash t. That will be equal to P mu1 to mu1 to will be this one, 1 to 2, given 2. So let me write 2 here. 2 P11 t and mu 2 to 2. 2 to given, that is minus 2 P1 to T. Okay. So in this case, what will happen is, if you see P11T here, that is extra. You have 1 to T here. Both are there. That is the problem. So there are some problems where you can connect 1 1 1 2 also. If you try to change 1 2, it will go to 1 3. If you go to 1 3, it will go to 1 2. Okay. So in these cases, you have to delete. Now how here, I mean, it's done actually. I will show you. This is done using this. Okay, P1 to T, using Kolmogorov's integral equation. Not because you can't use the differential equation what I wrote, but because this is easier. So what will happen is, Kolmogorov's equations are 4 in number. Okay, Kolmogorov's forward differential equation, Kolmogorov's backward differential equation. Forward, again, there are 2 types. Backward also 2 types: forward integral, forward differential; backward integral, backward differential. So in some cases, one will be easier as compared to the other one. Okay, there are some ways you should know. Even suppose you can use the backward equation here, that will be more easier as compared to forward. But I'm not going to backward equation now, or maybe integral equation now. I'm trying to use differential equation. Now, using differential equation, can you solve it? That's what you need to think. Yes, this is possible. We'll do it. Let me take this one. Let me copy this line, and we'll do it here. Let me write here this equation. This is differentiation, right? Let me take dy divided by dt, that is equal to 2 P11T. Already we have P11T. I think that was e power minus 3t. Here, though, it's already there. We found it. And then this will be minus 2. We'll write y here, minus 2y. So when you solve a differential equation like this, remember the formula: dy divided by dx or dt, whatever, plus py is equal to q. This is the general form of a linear differential equation. Okay. If you don't know linear differential equation, then you should remember this. Okay. This is a linear differential equation. Now the solution will be y is equal to, or maybe I can write this way. This is easy. Y multiplied by if, that is called integrating factor, that is equal to q integrating factor plus constant. Okay, this is the formula. So this formula we can use. What is if? If is equal to e power p dt here. Okay, because t is the time here we used. So here we'll find if here. Okay, let me find if here. If will be equal to e integration p dx. So in this form we have to write first of all. So I will take 2y that side, and this one I will keep here. So my p will be equal to 2 here. So in my example, p is equal to 2. So p dt, that means 2 dt, that will be equal to 2t. Okay. So my solution will be y e2t, that will be equal to q. Q is this 2 e minus 3t e2t dt integration plus constant. Now here y e2t I will write, that will be equal to integration. We have anyway e power minus t. You need to integrate. So 2 e minus t, again minus 1 you will get, plus c. Okay. So my y will be equal to e2t, you can take here minus 2, that will be et plus c e minus 2t. Or first you can put here and then bring here, whatever way you want, but we need to find c anyway. So to find c, you will use boundary condition. Okay. You replace y by p1 to t. So my p1 to t will be equal to e minus 2t multiplied by c minus 2 e power minus t. Then when you put t 0, you will get p1 to 0. 1 to 2 in 0 time, it's not possible. It will be 0. So if you put t0 e0 1, you will get c minus 2 e0 1. So c minus 2 you will get. I got 2 here. Okay, let's check. So if you put c will be equal to 2, so I will take 2 common. C, if you put c2, 2 e power minus 2t, you can take common. So 1 minus e power minus t. This is 1 minus e power minus t. We'll check it. So we'll put 1 here. 1 means 2 e power minus 2, 2 e power minus 2, 1 minus e power minus 1. Yes, correct. Okay, P12 is correct. And P13 not a problem. So what we got is, we got this one, we got this one. So you can get this one, not a problem. So everything is over, right? So let me write all here. So we started our problem with this. We started our problem with this, mu's, and from mu's we got p's. And the mu's, mu ij's, and p ij's, these are transitional probabilities, transition probabilities, right? These are transition intensities. Now these values were given and we got these values. E minus 3t, Pij t. Okay, if you solve Kolmogorov equation, you will get this. Then 2 e power minus 2t, 1 minus e power minus t. And the third one is A. A is big one, so A, let me write here, this 1 plus e power minus 3t and 2 minus 2 minus 2 e power minus 2t. You can get it always from these two because total sum will be 1. These are probabilities. Now these are probabilities not for 1 year. These are probabilities after time t. I will explain you this. How about this? This will be 0 e minus 2t, then 1 minus e power minus 2t. How about this? 0, 0, 1. 0, 0, 1. These are Pijt's. These are mu ij's. Mu ij's, they were given in the question. Let me write this. Minus 3, 2, 1. Minus 3, 2, 1. 3, 2, 1. 0, minus 2, 2. 0, 0, 0. 0 means these are the rate of change. So 0 means it's not that nothing, the change is 0, right? Anyway, I'm not going to the same thing time and again. So this, from this we got these values. Now, what is the meaning of this? What is the meaning of this? Now, if you go here, let me draw a timeline. Now, what you got actually, we started with this problem. These were the 3 states. If you remember, we started with these 3 states. And these 1 year probabilities were given. Not 1 year, sorry. Probabilities were not given. Now, these intensities were given at a very small time. These were given. And these were given. That means this, okay, these transition intensities. But we wanted to find, now we found, now what we found? From these, now we found these actually. These means we found these. Let me erase these 3 states. We are able to find, these probabilities. Now, what are these probabilities? These probabilities are, again, let me write time here, time 0, time t here. At time t, these are the probabilities. Okay. These are the, transition probabilities. We didn't find the probabilities. Okay. These are the transition matrix for time t, not for time 1. But if you see the question, in the question, it was given, find at time 1, see, determine the distribution at time 1. Time 1, if you want to find, because we got the probabilities here, 1 by 3, 1 by 3, 1 by 3, already these probabilities here. And if you get this transition matrix, this matrix is for time t, time 1. Okay, this is for time 1. T I have taken 1 already. No, I'm not taken. If you take T1, then if you take T1, then you will get one time period, 1 year. It could be transition probabilities. Okay, these are the probabilities. If you put T1, you will get these 1 by 3. You can use a calculator. 2 e power minus 2, 2, 2 e power minus 2, 1 minus e power minus 2, then a whatever value, 0, 2 e power minus 2. You just put T1, e power minus 2, 0, 0, 1. Now, this became like a transition matrix which is analyzed every time period. The duration is same, 1 year, 1 time period, 1 time period, 1 time period. That will continue. So the 1 time period thing that came once again. So it's exactly like a discrete time stochastic process. Now let me summarize. This is so important. Now many practical scenarios, if you see practical real world problems, uh, automatically they will come as a continuous time stochastic process. However, you might be required to analyze discretely. So whenever a continuous time stochastic process is analyzed discretely, then you must be knowing the transition probabilities. How you get those transition probabilities? For that, the only way is you need to solve one of the 4 equations. Okay, there are several probabilities you need to find from transition intensities. So where you get transition intensities, for that also you need to estimate from data. Okay, once transition intensities are there, how can you get transition probabilities? For that you need to solve Kolmogorov equations. That is the one and only one way. That's why it's important. Now, I will go to another problem. The second problem. This one here, this is the example. Now it says a Markov jump process is 2 states. The states are 0 and 1. And these are given 0.01 to 0.10. So if I write this, there are only 2 states. Unemployed, employed I can write. Okay. So people are unemployed and people are employed. These are the 2 states, 0 and 1. Again, transition intensity means what? Transition intensity, for example, this is 0.01. What is the meaning of this? Anyone who can say 0.10? 0.10 means what? 0.10 means 10 in 100. So 10 in 100, they become employed. I mean, not at that time employed. See, it's like this. What it says actually, there are 2 states here. Okay. What is the meaning? What is the meaning of this? This means actually you can compare with delta and I and mortality also. These are the 2 states. Okay. So now, although they've given this small, very small time, we are talking about small time, but the rate is for 1 unit, 1 time period. That means what they're saying, from unemployed to employed here, unemployed, here employed. Okay, I've written unemployed, employed. You decide your time period. Suppose this is 1 year, 2026 to 2027. So what they say, the transition intensity is 0.10. That means in a small time period. Okay, when you write mu, because mu ij's are not probability. If you want to know the probability in terms of probability, you have to take a small time period. In CM1 also, you remember, we have taken small time period, okay, dt. So you take a small time period, okay, then you can write unemployed to employed here on according to this one, unemployed to employed 0.01 or employed to unemployed, whatever you want. Suppose you want to find this probability, you have to take a very small time interval. Suppose this is h. That means what is, you need to convert to probability. That means that you have to multiply with mu. What is mu here? Let me write my generator matrix here. I have to write this way, 0 and 1. 0 and 1. These are given. 0 to 1 given, 0 to 1, 0.01. Because other will not be given. Some will be 0. Automatically it will be minus 0, 0, 1. How about 1 to 0? 1 to 0 is given 0.10. So this will be minus 0.10. Okay. So now here 0, 1, these are the two states and these are given. So when we talk about this transition, okay, if you want to get the probabilities, okay, you can say this h in small time period, you can say this h, okay. 0 to 1, 0 to 1, 0 is unemployed, unemployed to employed, or employed to unemployed, this is 10. When you talk about this one, 1 to 0, 10, that means 10 in a year. In a small interval probability, you multiply h. Suppose h is 1 second, okay, 1 minute. So that you have to multiply with this, okay. That way you can interpret probabilities, but these are not probabilities. These are transition intensities, okay. Force of transition, you can say, like force of mortality. Anyway, so here also similar thing. Write down the Kolmogorov's forward differential equation for the probability P01T and solve this differential equation to obtain an expression for P01T. So I will write P01T differentiation d upon dt, that is equal to, I will see whatever way possible, okay, P01T mu, because I want 0 to 1, 0 to 1 already you come to 1, 1, 1, plus I will write P 0 to 0 T mu 0, 1, I will write, okay. Then this will be, suppose this will be my y dash dy upon dt. This will be equal to this one, my y mu 1, 1. What is mu 1, 1? Mu 1, 1 is minus 0.10, minus 0.10. I will write mu 1, 1 here, P01T, P01T. Already we have taken y. So I got a linear form plus mu 01. Mu 01 is there already, 0.01 plus 0.01 P00T. Now this is a easy problem. Why this is a easy problem? Sometimes it will not be that easy. Why this is easy? Because there are only two states, dy upon dt, right? And then you take that side plus 0.1 y is equal to 0.01. Here P00T is given because P00T plus P01T is equal to 1. P01T is y you have taken. So this will be 1 minus y. Now what you can do is you can take everything to one side. Okay. For example, this is 0.01. This y you can take this side. You can make this form dy by dt plus py is equal to q. If you are able to write this way, then you are done. If you are able to write this way, you are done. Okay. You solve this differential equation. That's all. You are done. Okay. If you are unable to write, sometimes, it might be little complicated. So now the two problems I showed you and solved, these are the basic ones at a concept development level. You get in the exam practical questions. Okay. So the mathematical form you have to find. First of all, you need to know, you need to derive, you need to find the generator matrix. Okay. In case of this continuous time stochastic processes, then wherever required, you have to use, you have to solve, and you have to uh, get the values. Okay. Now I will go to another concept. Here, the duration is constant. That means you are able to write 0. That means someone is coming and observing me every 5 minutes, whether I'm continuing with the class or I left the class. Okay. Every 5 minutes. This is constant. Okay. 1, 2, 3. However, here, somebody sitting and watching whatever, someone is doing something, he will observe me only when I will make a transition, only when I leave the class. Okay. So this time is not necessarily 1 here. So suppose this is T naught. We are not interested in T naught here. This is T1, this is T2. So whenever there is a whenever there is a transition, okay, that means one will continuously stay up to this, and at time immediately before this time one will make a transition. Okay, I'm talking about continuous time here. This is anyway discrete time. This could be continuous time as well. We are measuring in regular time interval, that's all. So one will make a transition from here to here. Okay, that means you can diagram, I mean, if you want to write in a diagram, so one is making a transition from, for the first time, that means suppose T naught is equal to suppose 3 days, 10 days, 50 days, or 12 days, whatever you write. Maybe let me write 50 here. That means 50 is a big number. I can write 20 here. So what will happen is I will change my state from 1 to 2. I will continue to stay up to this. Just before this, I can say the continuous time. I will make a transition to 1 only here. Okay. So the force of transition, I'll make a transition at this point. It's like this point. Okay. So T naught is the transition. You can also say this way directly. I mean, the interval is so small. You can say staying here. You can say staying here and making a jump here. That means a time to, you are a time T naught, you are no more at 1, you are at 2. At time 0, you are at 1. Okay. So this is your occupancy probability. So in the first state, how much time you stayed, how much time you occupied state 1. Okay. How much time I'm giving you for this class, how much time I'm giving you. Then I will go to another state. Suppose I will watch news. Okay. That time, how much time? It could be 10 minutes, 5 minutes. Okay. That time will be counted here. So now staying here continuously and making a transition here. It could be here to here. It doesn't matter. Okay. According to the state diagram, if there is a possibility, you can come here also, otherwise here. Okay. Now here, so that means actually in diagram, you write continuously staying here and making a transition to this here, to state 3. So that means this time, this is another time. Okay, I've written T naught minus T1 minus T naught. You can say this is second time. Okay. So these are the times where there is a jump that is taking place. Okay. So if you find the jump probabilities, whenever there is a transition, then only you record. Okay. So these probabilities are different. So when I say Pij's here, Pij's here, Pij's, they exist from here to here. Again, I'm talking about time homogeneous. Here to here, here to here, with equal duration, these Pij's are there. These are Pij's. That's where we jump from one time to other time and we see how the process changes. This is a dynamic process. Here what will happen? These Pij's are jump chain probabilities. Okay. I mean, they are different than these Pij's. How can you get these Pij's? Yes, there is a little bit theory. These Pij's also you can get. So whenever there is a transition, that time only you are supposed to measure. Okay. So that means what happens here? The duration is not same. Okay. So you can't apply whatever you must have studied in discrete time stochastic process. But remember, when we started continuous time stochastic process, we still were able to get those equal duration from by solving Kolmogorov's equations. Okay, that was there. So Pij's still were able to get these kind of Pij's from mu ij's. That's what I solved with these kind of Pij's. The T was there. T I took 1. You can take 2. You can take 1 second also. You will get discrete time behavior from the continuous time that you will get. However, these probabilities are different. This is another thing. Okay. Whenever there is a jump taking place, whenever there is a state change taking place, then only you can measure. So though the same notation we have here, these probabilities are different. So there is a lot of confusion. Most of the time, students, they get confused. So I'll go to this one. Okay. I have a video also. I uploaded. If you want, you can watch from my playlist. The other thing I wanted to talk today, because once all theory is over, we'll jump to those exam questions, right? They are important. Ultimately, you need to prove yourself by passing the exam. Both are important. Conceptually, you have to learn. You have to apply also. Now, now, how can you find these? There is a change taking place. Now, if I take it as your, I can say Poisson process. If you go to Poisson process, in Poisson process, it starts from 0 and it goes like this, 5, 10, 15, this way. It goes like this. Okay. This is your Poisson process. What I'm saying here is, I mean, you can say, I mean, I can use surprisingly, though it's not surprise because there is a waiting time concept and there is a e power minus t concept. Okay. That was derived long before. The behavior, see, in Poisson process, you can't come down. There is only one way. In Poisson process, uh, you will start from 0. You can't go from any state to any other state. Okay. There is a, again, in these kind of Poisson processes, homogeneous. So what happens is there is a particular way we satisfy, like within a small time interval, all those I must have said you. And waiting time here, waiting time means here also waiting. Suppose you get the 5 claims, how you get? In different intervals. So in one interval, you will get 0 claim or 1 claim. Okay. Suppose you get the first claim here at time t naught. So 0 to 1. Okay. You got 1 claim here. So you will get another claim here. So in disjoint intervals, you will get claims. I already explained. Because in a very small time interval, you will get either 0 or 1 claim. You will not get all the 5 claims in 1 second and not like that. During one day, in different intervals, you will get one claims. Okay. So first claim you got in t time here, t naught time here. That is first claim. So what is the distribution of t naught? We proved also t naught followed an exponential distribution with parameter lambda. Okay. Then we started from here to here, this time. Okay. The time between t naught to t1. That is t1 minus t naught, you can say. Here I've written, here also I have to do that. Okay. This is t0 to t1. The difference is you can write this one. We'll write this way. This time you can give another, because these are inter-arrival times. Okay. So this time I can write, suppose what? I mean, I could have taken this as some other. T2 minus T1 I can write. T1 minus T naught I can write. But if these are the times, suppose this is U naught is equal to T naught, U1 is T1 minus T naught. These U's, they will follow exponential distribution with parameter lambda. How about here? This is a general stochastic process, not a Poisson process. This is your stochastic process here. In stochastic process, how can you find the occupancy probabilities? How can you find these? I mean, this is a future thing, right? Now you are, suppose you are here now. Now you are thinking, okay, when there will be a state change that will take place, when India will lose the first wicket, that way. It's not that you are watching every 5 minutes. You are just waiting when India will lose the first wicket, right? So that waiting time, that follows an exponential distribution. Here also exponential distribution. That is what I say, surprise. Here also exponential distribution. This was in Poisson process we proved. We never proved for a general Markov, I mean, this continuous time homogeneous Markov process. We never proved before. Okay. We have not gone to non-homogeneous. I'm not talking about that. So this was not done. Okay, this was not done. I mean, many students they use automatically. See, this is a Poisson process. This is your continuous time Markov process. This is not Poisson process. This will follow also exponential distribution. What is the parameter? The parameter lambda that came from this. This is a Poisson process with rate lambda. This was a Poisson process with rate lambda that was given. The rate here is 5. Here lambda is 5. That means 5 per unit time. But how you get? For that 0 or 1 claims in any interval. That's a separate thing. But your rate was 5. Okay. How about this? How about this? So here what will happen is if you go by this way, this one, this one, this one, I've taken 3 states here. Here also 3, 4, whatever you take 3, 4. Here also I can make 4 states. Now we are finding before going to, how much time one will stay here before going here. Okay. Now this will also surprisingly, that's the exponential distribution. Now in exponential distribution, what parameter you will use? How can you find that parameter? That is something that you have to know, that parameter. Okay. So for this also there is theory. So that is minus summation of, so it will be like this. Actually, before finding this one, okay, we can find this. You have to see how many, if it's, you are thinking it's going complicated, we can stop it here. Okay, just I am mentioning the result so that next time it will be easier. So suppose you are finding at 1, okay. From 1, where you can go? You can directly go to 4, right? You can go to 2 and 3. So all these will be given in the question. I will do next time. Okay. These intensities will be given. So using these intensities, you will be able to find this parameter. That is the only difference. Okay. So there is a concept of lambda I. Suppose I will write lambda 1 here. Then I will write U1 is follow lambda 2. How can you get these lambdas? Lambda 2. U3 will follow exponential lambda 3. How can you get these lambdas? These lambdas is linked with mu ij's. And from mu ij's, okay, even these also they have link with mu ij's. The jump chain probabilities, they have also link with mu ij's. Also, these probabilities, the transition intensity probabilities, transition matrix probabilities, they have also link with mu ij's. Okay, all are linked. If you want to get the in-depth knowledge on this, I have videos. You will never feel those videos good to watch. But yes, if you want to learn, you can watch. Some noise, all this during COVID time I taught. I uploaded those. The videos are already there. But I will give a class next time. But if you want to do before, you can go and watch. I explain everything. Okay. So here, these, I mean, the ways, the intensities of going out will be given. You have to add everything, multiply, minus, and that way you will get these parameters. Then, if you know the distribution, you will be able to know the waiting time. That's all. From the distribution you will get. We already use in today's class. So before I go complicated, I want to leave today. See you next time. Thank you.